Alright, this is the solution. This is number 11 from lesson 1B. It wants us to determine the magnitude and direction of each of the vectors in the given diagram. Express each vector as an angle measured counterclockwise from a unit vector in the positive x direction. Basically, all that is saying is find the magnitude and direction of the vector from the positive x-axis. Alright, so this is just considering, or think of it as, here is your east-west line and your north-south. Alright, that's all that's really saying. Not worded just the greatest. So I'll do two vectors for you, and then you can try the other ones on your own. But once you see how it's working, then you'll be fine. So I'm going to do an easy one to start. So my B vector, I can look at it, and it looks like it is 1, 2, 3, 4, 5, I think 6 in length. So the vector itself is 6 units in length. So to find a magnitude, we take the x component, which is 6 units long, no y component. So 6 squared is 36, square root it is a magnitude of 6 units. Oops. And its direction will be straight west. So 6 units west. That's all it really wants with that. So let me try a bit more of a more difficult one. Again, it's one of those questions where I'm sure once you understand what it's asking, the question itself isn't really that hard. So I'll do D here. So I'm a little tricky for me to see. 1, 2, 3, 4. I believe it's 5 units on the x-axis. So, and it's -5 because it's moving left. Plus, going down, 1, 2, 3, I believe that's 4 units. And it's going down. So that means I have the square root of 25 plus 16, which gives me square root of 41. You can calculate that or leave it as the square root. It doesn't matter to me. So that's units. So therefore, vector D is the square root of 41 units. And now for my direction. Whoops, I guess I got to find the angle. So part 2 to this, tan theta equals the opposite over adjacent again. So it's always the y component. So tan theta equals my y component. I don't need to worry about the negatives because I already know what direction it's facing. I think I said it was 5 over 4. So tan inverse 5 over 4. Bracket 5 divided by 4. So I have 51 degrees. So that tells me that my vector D is facing west. So it's facing west. Then I need to rotate 51 degrees to the south. And that would be my answer. Now that might not line up exactly with the answers in the back, but that's what I really want. This is the final product where we're heading with this whole exercise anyway. So you try the other ones and see how you get along, but that is the solution that I do want to see for questions like this one. If you have any other questions, please let me know.